mainly going to be talking about the nature of science. So I think this has kind of been a general theme of most of this professional development workshop, but it's also a standard that is present from K through 12. So it really doesn't matter what grade level you're in, you probably have to deal with the nature of science in your classroom. So we're going to be giving you an example using this lesson called Measuring Megalodon. So just quickly to introduce ourselves, for those of you that were able to attend the field trip yesterday, you got to meet me. My name is Victor Perez. I'm a PhD student here at University of Florida. I study the fossil record of sharks and rays, and I also got a minor in science education, so kind of have dual interest in science and informal and formal education. And then we have Sean, if you want to introduce yourself.
Sure, I'm Sean. I'm also a PhD student in vertebrate paleontology. I did my master's starting in 2011 at UF in geology and then switched over to zoology for my PhD. Right now, I'm actually researching 34-year-old mammals from Nebraska and seeing how they respond to climate change during this big event 34 million years ago. But starting in about 2014, I started doing a lot of outreach and education activities, including doing this lesson in both informal and formal settings.
All right. So basically, we are asking this question: how big was Megalodon? So Megalodon is thought to be the largest shark that ever lived. But if you think about it, our fossil record is going to be mostly teeth. So can anyone tell me why our fossil record for Megalodon is going to be mostly teeth?
Because it's cartilaginous and it doesn't have hard parts.
Exactly. So we have never found a complete skeleton of Megalodon. On occasion, cartilage will preserve, so we have found skeletons of other sharks, but we have yet to find one of Megalodon. For that reason, we have to come up with other strategies for estimating the size. So I like to think of this when you're starting this off in the classroom that you're setting up a narrative. So if you are a fossil hunter out in the field and you just came across this isolated tooth, it's bigger than any other shark tooth you've ever found, you're thinking this must have come from an enormous shark. How are we going to get from the point where we have this single tooth to figuring out how big the shark was? So I want you all to kind of think about this method and maybe type in the chat, or I think typing in the chat is probably the best thing so we're not talking over one another. Just give me some ideas of how you might set up a method to estimate the size of Megalodon when you only have its tooth. All right, just trying to get the chat up for myself. Okay, current sharks that are living, is there a tooth size to shark size ratio? Comparing to living sharks, compare teeth to current sharks. So we're on the right track here. Use tooth to length proportions of other sharks. Create a model of the mouth using fossil teeth. All right, these are all great answers. So I think it seems that most are in agreement we're going to need a modern shark to compare to. So we are going to call this our modern analog. And for our shark like Megalodon, what do you think our modern analog should be?
Great white.
Great white.
Great white shark. So are the great white and Megalodon related to one another? Or are they just similar to one another? Why the great white?
It's the largest shark we know today.
Whale shark is.
Oh, that's true.
Yeah, so that's right. The whale shark is actually the largest shark alive today.
Yeah,
But
except that whale sharks don't really have teeth like this.
Right.
Whale sharks have different type of teeth. So are you saying that a great white has similar teeth to Megalodon?
They do look similar.
Yep. So they at least superficially, a great white and a Megalodon tooth do look fairly similar. After years and years of debate, most scientists now agree that they are not directly related. For a very long time, people thought Megalodon was the immediate ancestor of the great white, but I'd say in the last 10 years or so, scientific community has largely shifted its opinion on that. So now they're actually considered to be in separate taxonomic families. So these are like cousins rather than, grandmother, father, son kind of lineage. All right, so let me get out of the chat and go back to here. All right, so you're absolutely right. We're going to use the great white as our modern analog. And the reason is because it is what we consider to be an ecological analog, meaning that the way it behaved within its environment is similar to how we think that megalodon would have behaved within its own environment. So these broadly triangular teeth that are serrated, they have a similar function between both of these sharks. That is to cut and dismember large prey. So ideally, some proportions of the shark tooth could be used to calculate or estimate a body size. So this is exactly what a paleontologist has to do, regardless of what fossil we're really looking at. We use modern analogs to make inferences about animals that are no longer alive. So a number of different people have made different types of estimates for the size of megalodon based on different tooth dimensions. And we're basically going to be applying one of those methods today. So that method was published in 2003 by a scientist named Kenshu Shimada. And essentially what Kenshu did is he measured what's called the crown height. So the height of every single tooth in the jaw of, I think it was 10 different great white sharks, where he knew the body length of those sharks. So using that, he was able to develop these linear equations. So one axis has his crown height in millimeters, and the other axis has the total length of the shark in centimeters. And then you just do a best fit line for each of those tooth positions, you get these linear equations. So every tooth position should give you a different estimate. And if it's working correctly, every tooth position will give you the same answer. So this is also referred to as a linear regression. So I want to direct your attention to this figure on the left here, because this is what you're going to be doing. You're going to basically be placing points to take these measurements on an online tool, for those of you that are able to get into Morphosource. So the width is going to be known as the crown width, and the height is going to be known as the crown height. We'll talk a little bit more about that during the tutorial. And what you're going to be doing is you're applying these measurements to what's known as an associated dentition of megalodon. So I did say we've never found a skeleton, but we have found associated sets of teeth. So all of these teeth came from one shark, and we're basically just looking at half of its dentition. So off to the right here, this would basically be the middle. And then this is the upper left and upper right half of the jaw. So what this looks like in the classroom, we typically would 3D print these teeth, have students kind of lay out the teeth to figure out where they fit within the jaw, and let them manipulate the teeth to take measurements and follow this method.
That's cool.
But since we can't give you all physical teeth, we're going to try to use this virtual tool to take the measurements online and go through the same process. I see some comments coming in, so let me open that up so I can see it real quick. Does that assume megalodon and great white have similar arrangement of teeth in the mouth, including shape, angle, and curve? That's a great question, and I'm going to ask that you save that for the discussion at the end. We will talk about that. All right. So the other tool we're going to be using is this R-Shiny app. So instead of having you go through the process of doing the linear algebra, essentially within this app, all you're going to have to do is indicate which tooth position you are using, your measurement in millimeters, and then you just click on size comparison up here, and it will do the math for you and show the estimate of your tooth from your tooth compared to the size of a great white shark. So I'm going to switch it over to Sean and allow him to introduce you to the tool we're going to be using.
Yeah, let me go ahead and share my screen. And one thing I'm going to do as well is in the chat, I'm going to go ahead and copy that URL of that Shiny app that we'll be using so that everybody can just click on that. Okay, so you should all have that in the chat now. So these two apps are relatively new for us. Usually when we're doing this with students, we have 3D prints of all of these teeth and we hand them out to the students, but obviously with the push to virtual, we've been trying to figure out how to make this more accessible in the times of COVID. So one of the things that we've done is we've reached out to Morphosource. So in 2014, we actually took all of these specimens, get this up. Everybody can see that okay now?
Yes.
I'm gonna take that as, okay, great. So we took this associated dentition of megalodon that Victor was talking about up to Duke University. And at the time at UF, we didn't have a CT scan that would fit fossil specimens. So we CT scanned every one of the teeth that represented the entire dentition that we had of this shark, and made those 3D prints available to teachers and for informal education at pop-up events and museum events and stuff like that. So what we can do is we can click on this K-12 megalodon. And when you do that, my computer's being slow, so I preloaded a bunch of this. This will take you to the page of all of the CT scans that we have of this shark. So we have something like, what is it, Victor? Like 20 or so teeth that we scanned, somewhere in that ballpark.
Yeah, I think it was 21 teeth, but we also did mirrors of the teeth to get the whole jaw.
Yeah, and we'll get back to that after we do the activity. But all of the data from these teeth are here in Morphosource now, and this is kind of a beta version, as you guys now know, that they're working on kind of around the clock that they just sent to us last week. So we're working on figuring out the best practices for this. But the cool part about this is the site that houses all of these data for our CT data. And when we click on a specimen, so we'll go ahead and click on this specimen, say, we can actually pull up the data and the 3D rendering of the tooth itself. So what I wanted to show you first, so now I'm having trouble getting to it, is on here, we actually use different nomenclature sometimes. So you can see that with these scans, we have an LL and a UL. So all of the teeth that are posted on Morphosource are from the left side of the jaw. This first L represents that this would be a lower tooth, whereas the U represents it would be an upper tooth. So in the case of this tooth, this would be UL09. This would be an upper left tooth in the 9th position. The reason this is important is it actually varies from the app. So as we saw on Kenshu Shimada's equation, we actually have different nomenclature here. So there's A1, capital A1, capital A2, capital A3. These stand for the anterior teeth, so the front 3 teeth. And then we have lateral teeth going back, L1, L2, L3. All you need to do is when we go to Morphosource, depending on which tooth you pick, if it's an upper left 6th tooth, you just need to count from the center of the jaw. So if we go back to our Shiny app, if we have a UL6, we're just counting 1, 2, 3, 4, 5, 6. So that would be the L3. So in this position, what we want to do is we want to say that's the L3. If it's a LL, a lower left tooth, we want to change it from the upper jaw to the lower jaw, and that'll give us the lowercase numbers. Does that all make sense? I know it's a little confusing, but it's just that, these two different apps use slightly different nomenclature to get at the same thing. In our case, we'll go ahead and look at this tooth to demo this, and then we're going to try to break you guys out. We'll see how this works, since a lot of people aren't to this line we created here. We should get this perpendicular line. If I hold shift, replace the next node. Now it's recording that one. So I want node 2, hit shift, go down here. So I'm going to get something in the ballpark of 98 millimeters for this crown height measurement. So once we have this, we can go back to the other app. So I'm going to exit full screen. We can go back to the Shiny app. We need to make sure that the upper or lower jaw is correctly selected based on our tooth. So in this case, it's the upper jaw. It's the L3, because remember we said it's the 6th tooth from the front. So that's going to be L3. And then I'm going to go ahead and type in my crown height measurement here. So we got about 98. Once I do that, I can look at size comparison. So I'll go ahead and click that. And this is our estimated length in meters of this shark based on this tooth position. So this megalodon, we have an estimate of about 14.3 meters, which is about 2 times longer than the largest the great white shark on record. So what we can do is we can do this for all the teeth. So oftentimes when we're in the classroom, we separate all of the teeth from the jaw and disperse them across a number of groups and have all of the students measure every tooth position we have. So what we'll do now, is there any questions that I'm missing, Victor, on the chat before we try to break out?
Yes, there's been a few, and I was going to try to respond to them, but I wanted to wait because it seemed like many were even though some people were messaging me privately, it seemed like these were worth mentioning to everyone.
Sure.
And Victor, we do have Julie from Morphosource here to help us.
Okay, great. All right, so first let me just answer a quick couple questions about printing these that people asked. So someone asked how much it typically costs. So at our university, there is a library that will print for us. And I imagine there's similar facilities around where each of you live. And typically the range that I've seen is between about $180 and $250 to print all 46 teeth. I think you'll quickly learn by the end of this that you don't necessarily need all 46 teeth. So that's kind of up to you. And then there was another one, can you get access to the scans? Through Morphosource, you can get access to the scans to download and print the teeth. Sorry, I'm trying to go through these and see which other ones I missed. Are these apps available for iPad? Will they work on Chromebook? I believe they will. I know that our Shiny app does, and I imagine this demo would work there as well. And maybe Julie could tell us.
Yeah, I believe that it should be working on a Chromebook. Yeah, because it's given that it's just a web app.
Awesome. Thanks, Julie.
Great.
Mm-hmm.
Okay, scrolling. Seems most of the other comments are about issues with getting logged into Morphosource. Did I miss anyone's questions? It's hard to scroll through this chat.
When you were drawing the line, I didn't quite get, like, are you right-clicking, left-clicking, holding down shift?
Sure. So I'll draw another line. It's not exactly what we're looking for, just to show you. So I'm left-clicking to place the node, and then I'm holding shift if I want to make a measurement to place the second node. So if I'm going from this point to this bisecting line, I'm going to hold shift, place it, and then I think what happened here is the node ended up on the other side. So just place with the left, shift, place the second, and that'll give you the measurement. Does that make sense? Great.
Yes, that makes sense. And also, like, if you click on the node, it changes the view of the tooth. How do you then manipulate the tooth back to its original?
So if you grab outside of the tooth and just grab the background, then you can manipulate the tooth and rotate it.
Thank you.
Sure.
Or you can disable nodes, and then you can manipulate from dragging on the tooth or off of the tooth.
Okay.
Back to settings.
All
All right.
So
Should we try to get people in the
Brian-
breakout rooms?